Time to start.
All right. Oh, I was gone for a second, but I'm back. Let's do day 9. Day 9. Who we got in chat? We got one lone viewer in chat. Who do we got? Okay, historians, blah, blah, blah. Something's not working. He shows you the disk map. I've heard this one's bad, by the way. And Paren, what's up, man? He shows you the disk map he's already generated, all right? I've heard this one's really bad, man. I'm not sure about it. We're gonna see. The disk map uses a dense format to represent the layout of files in free disk space. Here, let me... I'm not sure what to do. I hear the volume on my... once again, Clojure guy, thank you. Let me hide the iTerm, and now you can see my screen. Like I can hear my mic clipping, but the overall volume of the stream is quite low. Like, I just don't know what to do about it. Let me know if the sound is good. Maybe I'm too picky. I'm probably too picky. All right, and I can't hear it, so I can only ever hear it after the stream is over. The disk map uses a dense format to represent the layout of files in free space. The digits alternate between indicating the length of a file and the length of free space. So a disk map like 1, 2, 3, 4, 5 is 1 block file, 2 blocks of free space. Wait, 1 block file, 2 blocks of free space. A 3 block file, 4 blocks of free space, and then a 5 block file. Okay. A disk map like 90909 would represent 9 block files in a row with no free space between them. Sound seems good to you? All right, good to know, Clojure guy. Each file on disk also has an ID number placed in the order of the files as they appear. As they appear before they are rearranged. Wait, each file on disk also has an ID number based on the order of the files as they appear before they are rearranged, starting with ID 0. So the disk map 1, 2, 3, 4, 5 has 3 files, 1 block file with ID 0, a 3 block file with ID 1. I don't understand what's being said at all. Using 1 character for each block where digits are, okay. Using 1 character for each block where digits are the file ID and dot is a free space, the disk map 1, 2, 3, 4, 5 represents these individual blocks. 1 is the 0th. Okay, the 0th has 2 blocks. You had coffee, right? I might need another cup. I'm on half decaf now. I get 1/2 decaf cup, and then this is a full decaf cup. I might have to go full decaf for day 9. Okay, dot is free space. The disk map 1, 2, 3, 4, 5 represents, okay, yeah, I think I get it. So block 1 is ID 0, and it's got 2 blocks of free space. Block 3, because they're alternating, is ID 1. This is interesting, though. So the disk map, wait. Oh. See, that's weird. This part is weird. I don't really understand it, but I'll just buy it. Well, I don't know why this takes up 3. Oh, it's a 3 block file. The file is 3 blocks. Got it. Followed by 4 empty spaces and then the 2 block file. So the ID auto increments. Okay. The example above represents these individual blocks. 0, 0, 0 for 2. 1, 2, 3. 1, 1, 1 for 3. And then 3 empty. 2 blanks. 3. Okay, I got it. The amphipod would like to move move file blocks one at a time from the end of the disk to the leftmost free space block until there are no gaps. For the disk map 1, 2, 3, 4, 5, the process looks like this. Move 1, 2. Move the next 2. Move the next 2. Move the next 2. Start at the right. Okay. Oh, this is very visually satisfying. I'm going to have to print this out, maybe. The final step of this file compacting process is to update the file system checksum. Oh, here we go. To calculate the checksum, add up the result of multiplying each of the blocks' position with the file ID. We have inip0 with first time chat. Hi there. I started learning Clojure almost a month ago via the Brave book, so naturally I decided to do AOC. I've done every single day except day 9. No, I found it hard to express and I haven't tried it again. Also, I haven't seen today's yet. Okay. So far, I've heard a very good experience overall. I like the language. I mean, it's a great language, and it's a great language to do advent of code in. I think it's a great advent of code. Is just great problem sets, if you ask me. Inip0, have you done? So I am 2 days behind, right? So there's 9, 10, 11 are all out. Have you done day 10 then? Day 10 is easier than day 9? Don't say that. Okay, what was I saying? To calculate the checksum, add up the result of multiplying each of the blocks' position with the file ID number it contains. The leftmost block is 0. If a block contains free space, skip it instead. Multiply by, wait. The first few blocks' position is multiplied by its file ID number. Okay, so the 0 is 0, the 1 is 0, the 2 is 9, the 3 is 9. Okay, the 4 is 8. Okay, so just index across these. Use the index and multiply by the number that you find there. Okay. Okay, let's see the input real quick. Ooh. Woof. Okay. All right. So where's our example? This right here. Yeah, day 10 wasn't too bad at all. Well, that's good to know. Maybe I will make it till tomorrow. I wasn't sure I would make it through 2 solid weeks. I usually stop somewhere around 9 or 10. But if 10 is easier than today, then I'll do day 10 too, for sure. Zoom in. Everybody let me know if it's too small to see. Comment. We'll figure this out together in IPP. Never fear. A parse is, in this case, is really easy, right? It's just vec it. Oh, not vec. Parse. Actually, we want to get the digits out of it, right? There's a thing in character. Wait, no, it's it takes a char, right? No, value of. Oh man, there's a thing for this, and I can't remember what it is. Like you can give it a character, and it'll give you the integer back. The digit, character dot digit. Okay, how do you use this new syntax? Who's done this before? Is it like this? You know what? Forget it. Somebody can explain it to me and I'll fix this. Radix 10, right? This is a char. If I recall correctly, you can't put char. Like if I put char here, it gets mad at me. If I put it right here. Let's see. Yeah. Yeah. You can't put primitives up there. It's kind of dumb. But you can do this. All right. All right. This worked. If somebody knows the the syntax for me to do like the new thing. I just can't be bothered to look it up. I'm in the middle of something. I'm kind of in the middle of something right now. All right. All right, so we have the digits, and now we can make a representation like this in memory. How do we want to represent this? What's the data structure look like? Class name / method value is a Clojure function that invokes. Yeah. Wait, dot method. Yeah. Oh, wait. Yeah. This is a static, so we could do this directly. But my question is, how do I get? I don't think there's a good way to do this actually, because I need this 10 right here, right? Like I think I have to do some version of this to get that 10 right there. Could be wrong. All right. What does our state look like? Because we got to keep some state. It's got to look like this to start, something like this, and then we're gonna go over. We're just gonna iterate, you know, the compacting process. What do we have to know? We have to know the index of everything. Oh, dude, there is a clever way to do this for sure. But if you've been here before, do you need char? If you split it to string, you could just use parse long. That's what I do usually. Does that work? Oh, if you split it to string. Yes, if you split it to string, that does work. Oh, if you do like string split with what? Like that? With the empty thing? Does that work? No. Dot? I don't know. I don't know what you split on. I've never tried this before. Just split it. Every character of a thing. Oh, I did it backwards. Yeah, that works. I mean, you just got to recognize that a regex is going to be way slower than taking the characters of the string, you know? It doesn't matter. This happens one time. It doesn't need to be optimized. This is perfectly fine. I have somewhere kicking around that this exists in my brain, so I'm not worried about using it. Usually. Like, you saw how quickly I was able to track it down. Good one though, initp is true. I'm lazy. Partition. Does that work? I have never even tried. Hang on. Partition what? Partition null? 0? Is that? No. What do you do? Partition 0 call. No, wait, I'm stuck. Stuck again. Wait. What, 1? Partition 1? Is that? Yeah, 1, and then you get this. That looks harder. Then you gotta like concat it out. What, like apply concat that or something? That does it. I don't know. Okay, well this is more concise. Okay, in fairness, this is more concise than this. That's fair. 100%. Okay. Wait. We're trying to think of what is this thing? This is new behavior that I've never encountered before. It killed my REPL. I did just blindly upgrade Clojure version in this. Okay, it stopped. Okay, try again. I've never had it randomly die before. This is new behavior. Anyways, so we need some kind of data structure that's going to hold this, right? That's going to keep our state. It does, like, we have to be able to store a number at an index, I think. Like, there's probably a more compact way of doing it Tommy Vogler, what's up? InRepl up to date? I probably not. But there's a new thing, and I'm not going to update it right now. But there's a new thing in Java where you can't cancel things anymore. It might be related to that, like InRepl. Yeah, no, this is definitely not up to date. InRepl has to work around that fact. So I'm scared to update anything nowadays. I'm really irritated that Java's getting rid of thread kill. It's super nice to have in a REPL to be able to reliably kill something, but you know, powers that be say it's not safe. So here you go. There you are. All right. Focus. All right. So, I mean, it just needs to be a data structure in long. Now, this is pretty long, but like not so long that we should be afraid to store it in memory. Am I using cursive? Perhaps a plugin. I am up to date on cursive, actually. So I am using cursive. This is the IntelliJ IDE with cursive. Highly recommend if you're getting into Clojure. This is by far the best tool that I've used. Not that I've tried them all. Calva, I hear, is a very close second. I give up too. I'll look it up one day. I mean, there's a reason. I just can't be bothered, you know? I'm on stream right now. I'm trying to do something. I'm trying to solve this thing. All right, let's make our data structure. I mean, we could do this as part of the parsing process. Spit out a board that represents this as well. So this is the encoded example, right? Is that right? A dense format. So we can just call this the dense format, right? And we can call this the board or the layout. We're gonna need this. The DF. And I think we can store it in a vector. Like, I feel like this is gonna be legit. But each number will output more than one slot, right? So like this outputs these two output 3 slots total, right? So, you know, 2 inputs, we'll do a partition to all 2 here, right? 2 inputs will, you know, spit out n number of outputs. It depends on the number. Okay. So mapcat I with some number I. Well, no, what we want to do is comp partition all 2, right? And so what partition all does, partition all will, even if there's that hanging in one, all 2. What? Oh, I haven't done that yet. Right, so there's that 2 hanging on the end by itself. That's okay. And with partition all, it handles that and gives that to my function as well. All right. So in this, we'll get tuples. We'll get the, what do they call it? The left thing is called the file block, and then free space, right? File block, free space. And we're gonna do, like, I don't know, range file block, right? Like the file block has to generate, oh, we're gonna have to do a map indexed. Ooh. This is gonna be nasty. This is the index. This is the file block. Map over the range. Constantly. What? IDX? Right? Yeah, it doesn't matter what args you give it. Well, no, there's a function for that. There's a function for that. Come on, Pote. Repeat. File block. So repeat that number of times the index. And then what? Repeat nil free space? Like that? Is this a good layout? X is null. Oh. Free. Oh, it constantly. Wait, no. Repeat. Okay. Try again. Okay. File block is no. Hang on. What is this doing? Yeah. Tuple of index and then file block and then the free space. Oh. The last one. This one is nil on that one. So when free space. I mean, that looks roughly right? Yeah. I mean, I haven't compared it, byte for byte, but this looks pretty good. 3 nils at the start, boom, boom, boom. Yeah. So nil will mean free for us, right? And then it's just like a number shuffle, This isn't even hard, right? Let's do a step. I like me a step function. I don't know why I did that. I don't know why I just did that. So we're gonna take the current state, which is the layout. We take the layout. We peek, FYI, peek on a vec. Gives you the end, which is perfect for us, right? So we're gonna to move is peek of the layout. Okay, we get that one, but we don't want to pop it, right? We just, a pop would remove it. That we don't want. We want to keep it the same size. We don't want it moving on us. So we peek to get the value, and then we're going to do, okay, here's the dumb part, right? Look at this thing. This is gonna, oh my God, this actually may not work. I mean, we may not be able to hold this in memory. It's gonna be really long. You don't want a linear scan for the next nil, You don't want a linear scan for the next nil. Okay, so we can say, I think we could store this off. And just move forward. So start at a given index. So you're never gonna back up and rescan. You're only gonna move forward until you find the next index, I think. So the next, so IDX prime is going to be, there's not a great way to phrase this. Either we generate a lot of garbage. Like my mind is drifting toward loop recur, but like, Like we can generate a sequence of indices to look at. That's one way of doing this. We can loop recur. I mean, until we find one. That's another way to do this. Oh, we can, you know what? We could map index. No, we can't. You can't really map index. I mean, I guess you can. Would you be willing to explain what you're trying to do with the data at the current step? Yeah, Ebon, for sure. By the way, for everyone here, this is a joint effort. So if you have input, I'm more than happy to hear it. This is not about me solving it. It's about us solving it and having a good time doing it. So feel free to chime in. Don't feel like you have to hold your input. So we have a data structure that looks like this, right? We have a representation of that top line with layout, right? My approach is pretty different so far, so maybe you're on the right path. I don't know. Enip, if you solved it. Oh wait, no, you didn't solve it. Yeah, okay. So we have a data structure that looks like this, Ebon 4, and then we're trying to say, okay, get this 9 and put it at the first empty slot, at the first nil slot in our data structure, and then take the next 9 and put it at the next empty slot, and then the 8 goes here, right? And then the next 8 goes there. So you're just trying to take from the end and compact down into something that looks like this at the end, right? And so right now I'm trying to reason through, okay, if we have this and I have this number in hand, those are both easy. What is an efficient with an emphasis on efficient, right? Because this is going to be potentially prohibitively large. I might need to find a better representation than what I'm doing. This is going to be quite big. We do not want to start. What you don't want is to take this 9, start at the beginning, go get this, take this 9, start at the beginning till you get to here. Take this 8, start at the beginning until you get to there. Doing that is going to be, I can already tell, is going to be just way too slow. That's not going to work. Right? So we want a relatively efficient way to take this number, potentially where you are where I am, stuck. My naive loop recur worked, for example, and blew up reading the puzzle input. I Ripple 42. We'll see where we get. So we want to take this, potentially start at the beginning to get here. Yes, set at index 0, right pointer at the last index, recurring to you. Yep. That's where I'm moving. That's where I'm Ebon 4. That is where I'm leaning toward. Yep. That is what. Well, I mean, you can loop recur. You can loop recur, and that will be the fastest thing. Okay. Just saying that out loud, right? We started IDX. We let. Wait. Yeah, when. No. Put up a new vec using a transient vector. I don't know if that's helpful, but you can definitely go that direction. Yeah. Day 12 is the hardest day so far. 9, not so easy, particularly part 2. Okay. Transient vector is gonna be my next test. Yeah, if I cannot do this with regular vectors, I might try transients. Maybe. They can be faster, but they generate less garbage, for sure, right? And they can be faster. Okay, wait. Let's get the V out of that. Wait. See, the current index we're just going to say is not what we want. We're going to leave that off at where we left off, right? And so we're going to IDX prime is inc IDX. IDX prime is inc IDX. And then we'll get the value. Wait, yeah, I don't know if we need it more than once. If nil get layout IDX. If it's nil, then return IDX prime. Otherwise, IDX prime. This needs to be a cond. I was also able to read a list of ID count, nil count from puzzle input, but that's hard to reason about for defrag. Huh. I'm not quite following, but that doesn't sound fun. Cond. Okay. If IDX prime is greater than the count of the layout, then return nil, right? You have to guard the right edge of the data structure. If we get a nil, then we're good. This is free spot. Otherwise, inc IDX and do this again, right? So that should get us the next IDX that we need to do, look at, that we need to set. Okay. And then we're gonna add state. So it's on to state, layout. Okay, the way this is gonna work is we're going to, you know what? I probably will not use transients. If I have to optimize this, I will use an array. Arrays suck, but I mean, that's why they're there, you know? All right, so we're gonna assoc, good Lord, assoc onto the layout at IDX prime. Well, no, ooh. Oh, no, this doesn't work, right? This only works for the first one. That's right. And you said that, Ebon, like we had to keep another index. So this is the front index. Hang on. Ended. Back index? Whatever. Deck of the count, right? Deck of the count. Hit that back index. This is the F index. Yeah. Begin to end, left to right, front to back. E. I'm just gonna call this FI. And then the EI. We got the end index. Okay, so, to move is... Now this one, oh yeah, we do have to skip backwards. Bummer, man, we gotta do this twice. It's not end, it's back. Okay, we're just gonna do begin and end. I almost did that a second ago. Begin. Begin. End. BI. EI. Okay, so this one starts at the begin index. This one starts at the end index. And then we're gonna deck it instead. Do the exact same operation except for deck it instead of ink it. Okay. I mean, there's some concise way to do this, but whatever. So... Oh, wait. This needs to return not just the to move, this needs to return the val there. Right? The index. Whatever. It doesn't save anything, does it then? Never mind. Not without letting it, and I just don't feel like dealing with that. It doesn't actually matter. This is not going to be This is not going to be the bottleneck of the program for sure, whether or not to do that or that. Okay, so we're going to associate into the move index, we'll call it. Associate to the move index. Nil. We're going to do a few operations on the layout. Boom. Associate into the IDX prime, our value. Begin IDX is IDX prime. I'm just going to call you BI prime. End index is, I'm going to call that EI prime. Okay. Yeesh. All right. All right. Wait, even number of forms. Oh, else. No one caught that? For real? Somebody caught that. Somebody's letting me down. This is pair programming. Wait. I still got something wrong? Oh. I didn't fix this. IDX prime. Right? All right. Y'all my pair partners. Okay, so we parse it, and that's the state. And then we take one solitary step. And that did not work at all. This did move, that did move, but this did not turn to nil. So that's one problem. Oh. Maybe we don't want to deck this. Maybe we want to start with it off the board. Let's get crazy. That did not work. Hang on. End IDX. Let me parse it. It should be 19. This comes in, turns it to 18. Wait, this turns it to 18. Oh, this check. If for some reason this goes all the way to negative, that should not happen. Still not it. So it's 19 and this turns it to 18. This is the problem with looping. You can't get a sense of the data happening without resorting to print, which we can do. Okay, so if some reason this is negative, but it's not, it's 18, right? And then get LO IDX prime. Well, there's a problem right there for both of those. Okay. I am fixing bugs, but okay, it starts at 19. It doesn't even move it here. Okay. I was more thinking you're doing this all in one loop. Oh. No, yeah. I mean, we can do this in a loop once we have the step function. I really like having a thing that takes a state and then generates the next state because you can use it in a loop recur. I mean, the downside of this is going to be this data structure and creating it and recreating it. A loop has an advantage. You don't have to do this. But this is really nice conceptually because we can run this in a reduce and we can run this in a loop if we wanted to. So it is a little more flexible. Neither one of these things are happening. The begin index. I am really, I mean, actually, this is moving. 2, 0, 1, 2. So it's at the right spot. The end index is actually at the right spot. 18 is correct. This didn't happen. layout assoc at 18. Am I crazy? If I take this, assoc 18. No. 17? What's it doing? Am I crazy? What's it doing? Six, 555. Why are things happening right here? What in the world? Okay. Assoc? No. 0. Hey. 1. Whoopsie. 1. Hey. 2. Hey. 3. Must be on some kind of crack. Hey. Okay, 4. This does nothing, right? Oh, it keeps. Okay, that's. But only. Oh wait. But only up to a point. Okay. Which makes some sense, but this is 18 long, right? Or set 42. Chat. Help me. What is going on? How count of this is 42? Oh! Gah! Count a layout. Gah! Stupid computer. All right. It was 42. And we still get... Why is the end index 35? Oh! We don't want to do this. We want to do the opposite. If sum, then that's our thing. Yeah. There we go. There we go. And then we can step again. Boom. Let's go. Alex Babsy 123. Boo is correct. Boo is correct. And they're coming in here. Look, 9, 9, 8. Yeah. If I step again, this one's gonna be 8. Check it. Stupid mistakes. Happen to everybody. Boom. That one's 8. Boom. We're good. Okay, so we need to run this until... Ooh. What's the termination point? Oh, you found the chat, Alex. Good for you. You made it. Welcome to the party. The termination point is what? When begin or end? Yeah. When begin or end. Is this gonna? But this will. One of these two things will go to nil, right? Okay, so EI prime. That'll throw, right? We can go until we throw. No. Oh, okay. That'll be nil. Nil. I mean, we could just go until begin index is nil. I think. right? If this is sum and that is sum, then we can do this work. Otherwise we return null, and then that's when we stop, right? So if we do that, here, let's just do iterate. We may not be able to use iterate, but let's just try it out. Parse t, take while, sum. That was great. That worked great. Oh yeah, you can't check right, less than left because loops are separate paths. Yeah, I think you're right, yeah. Yeah. That might work with a loop inside of a single loop recur, but wrong number of args passed to iterate. One, what? Oh, iterate, wait. Takes a function, step. Yeah. Key must be an integer. Key must be an integer. I'm already lost my music. Key must be an integer. Where at? Where do we? No, there. Cond. Yo, con threader. We know what we can do. We just need to return null. We're at the end of the thing. Strep to step. When and then this one could just check some whatever. This is fine. What? Oh, BI prime. BI prime. Haskell wouldn't have saved that one. All right, so we got the last one. Whoa, team. What the? It went haywire. Y'all see this? It moved everything to the end. Okay, I did something real dumb. I might need to build a printer for this. So yeah, so it's moving 9 up, 9, 9, 9, 9, 9. And like everything's kosher for a second. And the nils are going on the end. And we're still good. We're still good. This is where we want to stop. And she keeps going. This is part of the AI takeover. Why did it keep going? Wait. Okay, so we're at 26 and 28. 26 and 28. Oh, you know, this is... What's it? It's looking from index until there are some. Going backwards. Okay, so this one will find something. Because it's going to start like what? Like, I don't know. All this is some going backwards, right? And this one is going until it can find nil. Ah! Yeah. It kept going even though it was more free space. Yeah. I mean, I guess I could do it right here, right? Like... when less than EI prime, BI prime? Does that work? And then I can get rid of these other checks. As long as... yeah, other way. As long as the beginning index is less than the end index, then we're good. If for some reason they're equal, we're done. Hey. All right. Ebon 4 gets a cookie. A Christmas cookie. You were right all along. I should have done this check. That was it. That was the hot. Okay. In principle, part 1 is ready. Let's check it out. Def in blah. No sweat. Never fear, no doubt. Oh wait. God, I do have to make like a way to run it, right? Part 1. You do get a cookie, Ebon. And look, let's just do this. Let's do the really dumb thing. And then we want the last of that, right? Oh, wait. I didn't finish doing I didn't finish doing it. And then you have to do this. Okay, and then you need to calc the result. All right, hang on. Def in calc. Okay, so given the layout, we need to map indexed the layout and it's index times value. Okay, we have a function for this. Util sum sumo util sum. Bring that in, and we're gonna do times iv. This doesn't need to be its own function. I'm getting wild. We be wildin'. Let hello layout. Get the last of that. Parse the in. Well, we just it'll be parsed when it comes up. Util sum of that. Right? Part 1 of parse the test input. Really? You know, that wouldn't happen in Haskell. We got a nil? Oh, wait. Of course. Look, we'll just do like a... This is not going to be the expensive bit. Yeah. 1928. Boom. 1928. This wasn't too bad. I haven't seen part 2 yet. But let's parse the end. Nah, it's like zero sweat, team. Come on. Give me a challenge. Let's go. I'm afraid I just jinxed myself. The eager amphipod already has a new plan. Apparently keep index is the thing. Okay, Alex. Hardy har. Keep index. But I didn't have to do this, like 1v. Well, whatever. Say 633-418. Boom. All right. The eager amphipod already has a new plan. Rather than move individual blocks, he'd like to try compacting the files on his disk. I might have somewhat overcomplicated my solution. Hey, init-p? We've all been there, brother. We have all been there. You should watch, what day was it? What day was it that we gave a wall of fame? AirDOS, day 7? Dude, mine looks like doo-doo and his looks like manna from the heavens. Go look at this solution and then go look at what I did for day 7. It's on YouTube, by the way. You can check it out on YouTube. Oh, I don't have a link to my YouTube? Oh, no, here it is. Check it out on YouTube. Mine looks like crap. AirDOS brings a tear to your eye. All right. Here we go. Attempt to move each file exactly once in order. Wait, okay. Pimp your channel in chat. Yes. Attempt to move. Wait, I gotta focus. ADHD. Rather than move individual blocks, he'd like to try compacting the files by moving the whole file instead. This makes sense. This makes sense, but it makes it interesting. Okay. This time, attempt to move whole files to the leftmost span of free space blocks that could fit. Attempt to move each file exactly once in order of decreasing file ID number, starting with the file with the highest file ID. Right, starting at the end. If there's no span of free space to the left of a file that is large enough to fit the file does not move. Okay. Oh, you want me to show my YouTube channel in chat too? I'm slow. I am kind of slow. Boom, right here. Check it out. Subscribe, like, subscribe. If you're watching on YouTube, like, subscribe right now. I don't know anything about YouTube. I just put it there so I have it for later because I did this work. Okay. So 9 can move here. Oh, paste a link in chat. Easy. Paste. Chat. There we go. All right. Thank you, InParen, for explaining all the things. You shared that short. Oh, yeah, no, Clojure guy, that short was amazing, man. I loved it. I loved it. All right. All right, so the 9 moves. There's no room for the 8 anywhere, so it doesn't move. The 7 can fit here. 6 cannot move. 5 cannot move, but 4 can move. Are we better off sticking with the compact form for this? I mean, you need to know the index. You need to know the index that you're on. Yeah, and to do that, you have to expand it. But I think our representation maybe isn't very good. Because you don't like this number of nils is not gonna necessarily be helpful. Huh. And then what do? You do the same checksum, you just ignore nils. Huh. I mean, you can definitely write those loop recurs to where like it backs up until the number changes, right? And then the forward one will say, oh, that was in number long, and then march forward until it can find a slot. But here's my question. Here's what I don't know. And maybe I need to go read this slowly. Let's say there was like a 1. And instead of this 8, no, instead of this 6, there was like a 1. Right? So would that 1 go right here? Well, like it doesn't matter what the number is, right? But like it's one number. So like instead of 4 5s, it's 1 5, right? Would this 5 go here? Or would it go here? It would go here at the beginning? You think, Ebon 4? Like it goes to the first... Here, I'll read it slowly. Attempt to move whole files. Attempt to move each file exactly once. 2 moves on the last 2 lines. Okay, okay. Ah, 2 in here. Okay, good call, in paren. Good call. Okay, so you do... You fudge. You start at the beginning every time. Okay. Okay. So you start... Oh no, this is bad. Team, this is not good. Okay. Huh. Yeah, it either goes or it doesn't. You can't split it up, but like I was wondering if like yeah, the 2 instead of yeah, something went back and filled the slot is the point, right? Okay, this one's kind of weird. But you do fill the slot. You don't just, you know, start where you left off and keep going. So we like the front index, in other words, has to be 0 at all times. It's got to recheck this. Hey, is there room for this? If you do it the long way. I'm thinking there has to be a way to do this where you don't do it the long way, right? Like, I don't even think the long way will work. Look at this number. This is insane. Like, that's, I mean, initially I was wondering if we can keep this representation. And in theory, you can, right? You can take this and say, subtract 2. So this is 2, 0 now. And then right in here, there will be a 2, 9. No, that doesn't. Yeah, that doesn't work because the indices get jacked. Like, you need the indices. But you need to remember that this is a 9, you know? Can we keep some kind of hash map? Some kind of lookup that says at this index, there are 3 blank spots, right? At this index, there are 3 blank spots. At this index, there are 3 blank spots. Or, I don't know, whatever. But then how do you use that? I mean, you would want to... I mean, ideally, you keep it sorted. Yeah, you need to re-update the index when you put a chunk in. Right. You got to keep the index in sync. But ideally, you also have it sorted, which is work, right? To sort it every time would be work. But I mean, it would be mostly sorted most of the time. You're only changing one index, and then you sort it, put that one wherever it goes. I mean, you could do it. Technically, you could do it with a vector. Like you could say, you could just have a replica vector alongside your main vector of the same size, which was fine. I wanted to try something with runs. I think partition by in Clojure, but then I realized I had to the partitioning every chunk move. Yeah, redo the, yeah. I don't think partition would work. I think if you keep a parallel vector, No. It can't be a vector. You need a hash map. I think you need like a hash map of like... Like on the left is free slots, and then the set of indices that have that number of free slots. Ooh, not the set. They have to be ordered. The sorted list, and it doesn't have to be a vector, right? But it has to be a list. So you can look at the first thing there, subtract your number from it, update this data structure with the new free slot. Does that make sense? Does that make sense? It's very grug brain of me to do it this way. I feel like there's an elegant way to do this, but like my default is, okay, if it's going to be too slow, cache it, right? And this is the only caching I can see offhand. This feels very much like the Linux kernel ext4 extent management. That's the beauty of Advent of Code, though. Like, I would never... you don't encounter problems like this, usually, you know, in real life. It really pushes you to, you know, develop novel data structures and algorithms. It's awesome. And I know... I didn't take comp sci or whatever, right? Like, I don't have, like, the background. I can't whip out the name of the algorithm we need to use. It's perfect for this case, you know? I think this works, though. I think this will work. If we have... Okay, yeah, we just have... Hey, here are all the free slots in the system, and the ordered list in which they appear, and we keep that up to date as we go. That's a constant time operation. They keep free block data in line. Makes me wonder if you can do that. Yeah, like keep it in the layout. You could, if the items in layout could have metadata, but they are numbers, and in Clojure, numbers don't get metadata. Yeah, I mean, an alternative... But even that doesn't necessarily help with this one, because you're still going to have to just go searching from the beginning. Like we could say, you can add metadata to anything, any kind of iMeta, right? Look. Oh, sorry, iObj. iObj, which extends iMeta, so it's kind of redundant. So this includes basically everything. Yeah, it is Alex Alex Babsy. It is any iObj. It's interesting because that actually extends iMeta, so they're one in the same statement. Well, I guess you can implement iMeta direct, but this is basically most things in the Clojure data structure set. Alex ABC. That makes sense. Alex B ABC. That makes sense. I'll try to do that next time. So yeah, you can put it on most things, but you can't put metadata on like a number because that's not an iObj. Foo's bar, right? Class cast exception. Cannot be cast to iObj. It's unfortunate. But I also think it doesn't help in this case because you would still end up having to scan forward. Okay, I'm looking for a slot 2, right? Scan forward from the beginning until I get to a slot 2 or greater. So I think this is going to be the hot. I mean, either this or like, I don't know, like a sorted set that we keep resorting. I think this will be enough. This isn't perfect, but this will be enough. The IOBJ makes sense. The meta has something to hang off of. Yeah. No, I agree with that, Alex. I agree with that. Okay, so look here. Let's go ahead and parse this out. It can happen on both, right? Our free to lock. If Clojure used protocol, if I don't know what that star is supposed to mean. Things get obstructed in chat. I can't tell. Use protocols, and it could have been if Clojure used protocols, it could have been extended to IOBJ. Yeah, that would be cool, Alex, but also very expensive. I kind of I don't know. No. If it's on protocols, then it's only expensive if you call the protocol. Yeah, no, it would have been cool. This has to be a transduce, right? We're gonna map over the. Assuming I understand correctly, pass through the line. Hang on. Pass through the line. Record free space block says block start, block end. Do the same thing for files, but starting from the end. Do this until, like, the first step, your position is less than your left position. At this point, you'll have all the free blocks and files, and will complete the first step. You can then step through the files, inserting them into the free space when it is possible. But the protocol would still have to find a way to store the metadata somewhere. Yeah, that's right, Alex. Yeah, no, Ebon, the problem I'm seeing with that approach is that you have to start from the beginning every time. And this is too big a thing to start from the beginning and look forward, right? We have to have something that tells us, hey, jump to this spot in the data structure. You know, like from here, jump to here. Don't start from there. You know? If we can't jump in, I think it's going to be ungodly slow. I mean, this is a guess, but this is a big data structure, you know? You're going to have to iterate to find the right locations no matter what. Yeah, with this, you're going to have to iterate over the data structure, over this thing. Right? But then you can jump into the layout at the right spot and just do the assoc straight up. Just assume that that's a good spot for it. And focus on keeping this thing up to date. Right? I don't know. We're going to find out. This might be a bad plan. Might be a bad plan. But I worry about the timing implications. I've heard a lot of chatter about, hey, my thing took way too long. So I'm going to do the thing that I think is going to be fewer steps. We're going over the layout. Completing. If we're going over the layout, this will be just a number, map index, right? I and V. Oh, this should just be a vector. This is the free to lock. Free to lock. You're free to lock, baby. Let's update. Free to lock. You might be totally right, Yvonne. I might be like way off base. But I can't see it yet. I'm too done to see. F nil conj. V. I feel like this will work. I don't have the foresight. Let's do a parse of n to see, a parse of t to see where we're at. I need to init. Miss this every time. Init that with an empty hash map. I think you could do my method in one pass, but it makes it harder to reason about. Yeah. Did you do a solution, Ebon? If you've done one, we should look at it after the stream. and I can see what I'm missing. The 0 slot. This is not correct. This is not correct. Oh, I haven't done one. I'm just following along with the stream. Okay, okay. If you do one and you come back, I'm happy to look at it. This is not. This ain't right. This is nowhere near correct. I'm wondering. No. This can't. We can't just do a straight transduce, can we? Then this doesn't work at all. Unless. Oh no, are you serious? No. 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 Okay, we won't use transduce, right? We'll just use split width. I think this works though. So this should take the layout. Let's just bring this down here and play around a bit. Layout of parse T. No. I want like partition width or something. Why isn't that a function? Oh, partition by. Hey. 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 XF. Is there a partition by? No. That's unfortunate. Whatever. This is good. Okay. Partition by the layout some, and then I think we could transduce this if we wanted. Map each one. Map indexed. Wait, no. Ooh. This is awkward. This is so awkward. Here, hang on. Let me try and make this not inscrutable for the team. Okay, so we need to know at index 2 there are 3 empty slots. At index 8 there are 3 empty slots, right? This technically gets us that information. Because we can do map. We can look at the IDX of the first thing. I think it has to go like this, actually. The IDX of the first thing. And, well, as part P. And then we want to spit out the IDX and the count of P. Sort of. We want to keep when the val is nil. This is so awkward. You can tell it's not the best answer when it's this awkward. This may not even work. Let's just see. At 31, there's 1 slot. At 35, there's 1 slot. Yeah, this looks right-ish, right? This looks fairly correct. fairly correct. And then transduce that into a hash map. Let's update accumulator, the IDX, fnil, conj, the set, that count, starting with an empty hash map. Starting with an empty hash map. Okay. Stack Overflow. How did that cause a Stack Overflow? Oh. Wow. That'll do it. Okay. Wait, do we want the index? No. No. Switch this around. At C, for C, there is an index. If you want that kind of stuff, there is an index. So if you want 3, oh, we don't want set though. We don't want set though. Bad. Bad. We need them ordered. That way we can sort here. So if you want 3, you can go to index 2. So 1, 2, and 3 can fit right here. So basically you need to sort this every time. That stinks, but I think it'll be okay. There is like a sorted hash map, isn't there? There's a sorted set, I know that, but whatever. Stop thinking about it. Just try this. Okay. Does advent of code allow libraries? Oh yeah, baby. We got big libraries. Big, very big. There is a sort. I know there's sorted hash map implementations around. I'm gonna try just with a straight, hash map for now. Yeah, there's a sorted set, I think, in set, right? Or is this just a sorted set in... Yeah, this is a sorted set in... Oh, there's a sorted map. I think that might be what we want. That might be. Hang on. Like this. That's a good question. That is newer. No. No, I don't believe this. I'm in the same boat. I know there was a sorted set. I knew sorted set was there. But sorted map came at the same time? Kind of unbelievable. Okay, so now it should print in order if I parse D? Yeah, it does. Sorted set by to keep a set of files, IDs ordered by their position. Yeah. Yeah, and in theory we could use this as a sorted set as well. But we don't need to because they come in order and we just keep them in order. We'll just be diligent about how we touch this thing. I don't think that's too bad. Okay. All right, so we have free to lock. We are now free to lock. Let's just... No, we need a step. We need a def in step star or something. Right, and so we need some version of this. I don't know if we need... We do need an end index, but now begin index is irrelevant. So we're going to start at a particular spot, the end index. Look. All code cleanliness goes out the door when I'm trying to get it done. End index does this. It's the exact same logic, right? You go backwards. you sort of go, it's almost the same, except, except you need, like, you can't start, you know, here and then go one step. You have to go until this number changes. Go until you hit the 8. And then, so it's indexes. It's not index. Because we're going to have to update both things. Like if we're going to keep the original data structure along with this cache, basically, then we're going to have to update both 2 slots for this operation, right? And how does it work? How does it work? This is fine. If for some reason it goes negative, if we need to know a val. And so this is if not equal. Get the current valid EI. It'll be nil if it's off the edge of the thing, right? Go until the val is not equal to get EI prime. Index. We'll call this EI prime. Whatever. Index prime. And if you find that, then return ret. Conj ret IDX prime. The ret doesn't necessarily have to be in order. We can update them right to left. That's fine, I think. Else recur I kind of wish it'll be better if we do all the work in one spot. Go ahead and deck the IDX. The V, if it's nil, right? Do we need to, if this is nil, we can just keep it as nil. No, we need to re-get it out somehow. We got to get it back out somehow. I think we just keep moving it back. We can just call this IDX now. I think we just keep moving the value back. Yeah, because this could be nil on the first time and we want to get the new value. If index goes negative, then we're done. If we get something that's not nil, This isn't right. If it's some value and not equal to our new index, but then this doesn't work. Oh no, this works. This operates one behind. I think this works. Okay, let's just return EI prime real quick. This is step star. Step star. Slurp. Okay, that's awkward. 9. Oh, wait. Not the value. Okay, 39 and 40 are the right indices. What is this empty? Where'd that come from? What is this? Oh, no, conj is fine. Anyone have any idea where this stupid empty vector is coming from? This is only ever a number. Second con case. Boom, boom. If this is sum, and the v is different than our new index, then conj on to ret our current index, and we're done. Return. This is at the beginning, though. It would be at the end if it's on the return statement. Like it's getting initialized. Oh, this con statement doesn't work? Second con case. Does this not work? I don't use con threader very often. Oh. Yeah, there you go. I don't use con threader very often. Okay. Boom. Okay, so this is correct. This is the EIs. Right? And the last value of EI is what we want to return as the new end index. So we can go ahead and say assoc onto S end IDX, the peak of EIs, right? In this case, 39, the thing most towards the beginning, right? Layout then is going to be a reduce on the EIs. Wait, we're not quite here yet. We're not quite here yet. There is going to be a reduce. There is going to be a reduce, but we're not there yet, right? We need to get where we're going to put these things before we're ready to return. So we have a sorted set. in what's it called? Free to lock. I don't know. IDX. Right. We want to filter. We could do some. Count locks. When count is greater than or equal to the count of EIs, because that's how many indices we're trying to move, right? Then return the first of locks. Right? So that'll be the update index. And then the update that we need to make to free to lock is at that point. Ooh, we need to do 2 updates. At this point, at index, we're going to have vowels, right? Vec of rest of vowels, right? We chop off the first thing. It's no longer in this set for sure, right? And then we need to update. This is a con threader. Con threader. Always do this. Always is not a special keyword, by the way. It just returns always a value. So this will always get run. You could say anything right here. But then we want to say, hey, if it's not negative, no. If it's positive, the subtraction of count EIs ooh, we need to know how many. Subtract from C count EIs, because that's how many moved, right? If C prime is pause, then we need to update C prime. I kind of wish this was a sorted set now. I'm just going to do it. I take it back. If that's sorted, then we could say disjoin, dissoc? Or is it disjoin? Take that out of there. And then conj this, right? Now it's always going to be sorted. First will get me the actual first that I care about. Oh my goodness, this is like bonkers, y'all. This is anti-fun. All right. Let me see where we're at if I step. Okay. That didn't work at all. Wait a minute. Wait. Oh, no. We do... Really? Disjoin. How did 2 become nil? F... Oh, right here. F nil. Conj. Sorted map. No? Well, I think this is still what we want. Like if... Wait, no. Yeah. If VS is nil, we just want to use a sorted map. I guess, what's a better way of doing this? Like the more Clojurean way is probably like this, or sorted map, right? Sorted set. Oh my god, this is the first time we've had to cycle the music twice. This is a long stream, team. I don't think this is incorrect, though. I think this might be correct. So it's after one step, slot 2. 0, 1, 2. No. It should not have 3 free slots, right? It can't be both here and here. That's the problem. Disjoin set key. Look here. Let's see what it's trying to do. So it's saying, hey, the count is 3 at slot 2. C prime is 3 less, presumably 2. For this, we're going to update the index, taking out... Oh, wait. Update C. Update C, yo. There. There we go. There we go. There we go. All good. Oh, this is another one I'm not super proud of. All right, now for the layout. Finally. Okay, I think we're keeping this thing in sync. I think we got all the data we need. We can finally do our updates. So we need to do a couple of things. And we need to do it in 2 steps. This is awkward. Yeah, this is awkward. Okay, we'll just do it down here. Let layout. I'll go ahead and do a reduce on EIs, right? And the EIs are just indices. And we're gonna... Wait, accumulator. Set those to null, right? Because the things in the end just got straight set to null. And then we're going to reduce... range IDX to count EIs plus IDX count EIs. From IDX to the stop point. On LO. Assoc onto the accumulator at that IDX. Do we have the value? We had it here. But I don't think we ever return it. Which is fine. We can just get it back out. We can just get it back out. But we do need to rename this if we're going to do that. View the AOC page. Yeah. What do we got? I'll zoom in. What do we got, Ebon? Okay. The URL, by the way, is... oh, you can't see part 2 if you haven't done it. I see. Assoc accumulator IDX get. Yeah, let's just get the value. Get from LO. Wait, no, get from LO the peak of EIs. This is good. Okay. And then this is just going to be associated to that value right here, right? I think. Woof. Oh, it didn't work, team. No. This worked though. That's good. Oh wait. Yeah, we already have end index. Okay. Why didn't it bring... Wait, it brought 2 8s over. Oh wow, this is really... Wait. Why did it bring 2 8s over? Eh? Why'd you bring 2 8s over? Tofu, the lofu. Clojure. That's right. That's why we are here. For the Clojure. Okay, so this goes and gets from our cache. The index that we're going to update. That's this guy. And then we update that starting at that index forward. See, this works. The question is, why did V... This should not be at 8. Let's see. End index is 39. End index is 39. Starting at 42. 41, 40. Why is it 39? 41, 40. Oh, 39. Index is right there. Oh, did I return one too many? Oh, do I not want to conj that? I think maybe I don't want to conj that. That makes sense, I think. Wait, no, red. Okay. I think that makes sense. That apparently doesn't make sense. back up one from the index. It starts off the board. Deck it. This is the prev value. Yeah, you definitely don't want to do this. You just want to return the ret. Because we've moved off of it at this point. If there's some... Okay, let's just see what this is returning. This is definitely the least fun stream. Oh, I might have to stop. I need to stop around 1. EI's 40. But it says it's 42 long? Layout. Count. So it should be 41 and 40. And we lost 41 somehow. Oh, conj. Wait, no, you don't want to. Oh, I see the bug. This is going to be nil, and this is 9 at the start, right? Well, yeah, this is 41 and nil because the prev is nil. So the question isn't is the prev V. Is V prime. V prime. If V prime has a value, then we need to go ahead and put this index in there. This is kind of a wonky way to do this. There's definitely a clearer way to do this part, but I'm not going to think through it right now, I think. There we go. Nil, nil. And please, please, 9, 9. 9 times. 9 times. Hopefully y'all get that reference. Hopefully chat remembers that reference. 9 times. Okay, so we should be able to step again. Whew. Step again. Yeah, I think I left something off. This sounds right. Count EIs. Okay, there's a bug in here again. Where'd it blow up at? What's it missing? Index is nil. After 1 step. That can't be right. Wait. after one step. Wait, did I step even? Wait, this was working a second ago. I just made some changes. Parse T. Okay, let me undo my changes. Undo my changes. Okay, that works. End index is 40. EIs is that. Okay. So it's not able to find EIs the second time when it's starting here. Right? It's 41, 40. Get the prev value. Get the index here. That'll be 8. It's blowing up at what line? The count. Okay. Or, I mean, I guess it could be C is not here. Just print line like an animal. Well, I don't know. Yeah, never mind. Right. C is no. So EIs looks correct, actually. 39, 38, 37, 36. But C, it didn't find... Oh! Of course! It might not find it. It might not find it. It might not find it. If it doesn't find it, we're just moving on. We're done, right? So this is a... Guard everything behind C prime, right? If there's a C prime, then we do that. Yeah, let's just do if C prime, if then free to lock. If C prime, then layout. If not C prime, then just return layout. Uh-huh. Nothing changed. 8 did not move, but I should be able to step again. Did the 7s move? But the 7s should move. End index is 36. It's like here, I think. Which looks correct according to the EIs. And we're going to back up. But it didn't get... Yeah, end index is nil. EIs is empty. There's a bug in here somewhere. And we still don't have the termination condition yet. So like there's going to be a bug at the end too. But 36, so 41, 40, 39, 38, 37, 36. Okay, this is an 8 and a nil. That's the bug right there. We have an 8 as the prev val. And they're not equal, and so it just returns red immediately. Yeah, so this whole thing is wonky donkey. I'm loath to rewrite it, but I think I have to. So if we get the value out directly. And say we start with the nil as a prev, always. And we say, hey, the prev had some value, and that value is not equal to that. Wait, what does it do? Yeah, get layout the deck of IDX. Just do this twice, whatever. And if that value is something, not nothing, now we can let IDX prime. So we don't have to do that 10 times. We can just do this. We actually don't have to do this. Right. Right, so we return our value that we get the value out immediately, and then we deck it to get IDX prime. If we get down to it, we do that, and we return our current value. So this will always be the prev, and it'll start with no. Right, yeah. I think this does it. Let's just see if it runs one time. That looks good-ish. 2 times. That looks right. There we go. And the 7's moved. And the 1's increased and the 3's decreased. Okay, so how do we reach termination? I think it's the same check. When they cross, we're done. Right? Is that true? No, there's not a begin index. It's when you've seen every number. Oh my God, so irritating. This is so irritating. Okay. So it's... That moves, and you're done. There's no free space. I mean, are you done when you've seen every number, every index? Is that the deal? Like you have to keep going. I think yeah. We guard everything behind EIs, right? When EIs, because it'll return no when it hits negative. So we just go from the right all the way to the left, and we're done. Okay. That wasn't as bad. I was being dramatic. I was being dramatic. All right, so if we say def end part 2, and it's the literal exact same, I think, right? Like we're just gonna run the thing, take while there's some value, get the last value out, and then sum up that value with the same algorithm as before. Looks correct-ish. So I do part 2 with parse t 1928. That is not correct. That is not correct. But it did run, so that's interesting. So let's see. Let's do this with part 2 real quick. Huh? This looks actually... Oh, no. Oh, no, it broke up the 8s. Why? Why would it break up the 8s? We know it didn't do that before, right? So let's not do that. Let's do this. Let's do take 20, take 10. Oh no, by then it's already done it, but we know it skipped the 8s at one time, right? No, it's like moving them in pieces now. Hang on. Let me clear this. Start at the beginning. Hang on. I wonder if I can like map. Layout. Well, does that just work? Hey, that's not too bad. I could do slightly better than that though, I think. Okay. Oh, no. You want those nils. Whatever. Oh. How did this happen? It's not... Okay, the E... Oh, I broke EIs. I broke EIs. Is it still returning them? Yes. So let's take 3 of that. EIs. Huh? EIs. It's supposed to be... It says right here. So when EIs associate that. Wait. Yeah. Oh no, team. Wait, did I do the same thing? Oh, no. I don't blame chat for not paying attention because this has been a long one. Okay, we got some kind of other problem here. Let's just do seek. No, you can't. Yeah, no, let's just do seek. Why? Hang on. Okay, this looks correct. Okay. We got to here, which I think might be the final state of the thing. The last move is 2. Okay, it's trying to do the last move. Maybe. And it farts out? But there's the EIs. Hang on. It's 17, 16, 15. Why is it? It's like way over here. Like maybe here. Oh, wait. You know what? You're not supposed to remove a freaking number. Okay, so we need like a scene. If or not C or scene V. Okay. Okay, immediately vomits because scene is null. That's right. We can go ahead and initialize that here. Okay. Okay, we get pretty far. Again, back to where we were. So I didn't fix anything, but I realized that was going to be a problem because it was going to get to the 3. Well, it did move the 3. No, it moved the 4. But what is it? Okay, so IDX is no. Which I think is okay. It's supposed to be okay for IDX to be no, right? Oh, but C has a value. How does C have a value? Oh, this needs a and seek locks, right? There's something there, and okay. 2836. No, it's close, but it's not right. No, 2858. 2858. Hang on, let me get rid of the print lines in here. Print line. Get rid of this. Is that it? Okay. Oh, okay, so what is that garbage? 9 moves. 8 does not. 7 moves. 6 does not. 5 does not. I'm not quite sure what the timing is here. It's probably related to the bug, but 4 goes to here, which seems, I think, is correct. And I don't know why we sit here for a while. Oh, 3. Can't move. And then it finds that 2, and it should put it right here. And instead it does something completely bonkers and overwrites the 9. That's really weird behavior. And then it does nothing for a few steps. Which make okay, no, that makes sense. That part actually makes sense. It's working through the rest of the thing. But why did it update index 3? We must have a bug in this. Zero, 1, 2. Here, let's see. Let's not. Let's just print out everything. Wait, we want to do. Yes, state. We want to associate on the state the stir of layout. Oh, for layout. Oh, we can just see it. There we go. But in line with all our data is the key. That's the key. All right, so, all right, let's see what all we're dealing with. Did I get rid of EIs? Oh, there it is. Okay. So 40 and 41, that's moving 9, and then backs up and gets the 8, and it's like I can't do anything with that. And this does not change. It looks correct. And then it's like, okay, the 7s. 3 7s I found. And I've seen 7. That's good. And it says, okay, there's no more 3 slots for slot 8. It moves 7 to slot 8. That's correct. And then the 6s. And it's like, I can't do anything with that. The 5s. Can't do anything with that. And you can see it's seen a 5. We're good. The 4s. It's like I can put 2 4s at slot 12. Boom, boom. Okay. And conjured in. Good. The 3s. Can't do anything with that, but I've seen it. Found the 4s again, but I've seen it. So ignore. So it should have ignored. Found the 2s. Found 1 2. Oh, this is not a sorted set anymore. Well. Oh wait. 0 1 2. Why does it say there's 1 slot available at 2? How long has it said that? It wasn't there here. This is incorrect, right? Take that out. Take in f of L. Update C prime. It should be 1. Conj into there, either this or that. Okay, at slot 1, what do we need to do? We need to update this slot by adding in. Where is... Not, okay, not index. It's not index, it's the plus of index and C prime. Right, you gotta undo this. That's even more wrong than before. Let's go look and see if we fix that bug. 0, 1, 2, 3. That's not quite right either. Do you have to, do we just like blind ink it? Yeah, it's the ink of that, right? Ink of this. Because you got to move it one more over from where you sit. Two 858, and boy does that feel bad. This is the worst feeling correct answer I've ever had in my life. In my life. But it does look like it did it. Screw it. Screw it. Does it even work? Now we find out. Was it off or not? Hey, it worked pretty fast, actually. Maybe the slow version would have just been fine. Team! Too high. Too high. What are we missing? That's too high. I said at 1, didn't I? It's 120. This gives you some insight into my psyche. I do not want to give up. Using this method instead, right? Whole blocks. Why would it be too high? You can't just print this out though. This is crazy. We can't just like debug this. That's the problem. Like you have to look at your logic and the example. Replace nils with 0 in the checksum. This does check for nil right here. Yeah, we remove nils. Right? Is it not? Is that not correct? That was my read of this. Add up the position with the file ID. The leftmost block is in 0. If it's a free space, skip it. Yeah. If it's a free space, skip it. Team, I thought we were there. Nils aren't only in the end in part 2. This doesn't... This looks over the whole thing. It came up with the... For the test input, it coughed up the right answer, right? Let's look at this and see if we can find an error in the way it's doing. Maybe it just happens to cough up the right answer here. Otherwise, I might just have to pause and be like, I don't know. I don't know. Okay. Slot 2. Is it that? Here, let me just print the layout. Yeah, I think I got that. All right, let's see if this. Let's see how off this is from this. We just gotta make sure everything is exactly right. And it looks like there are already just too many lines, right? Well, I don't know. I guess it depends on how you. Okay. Okay, so we move the 9 over to here. That's good. 8 stay put. We have a blank iteration here, which seems not good, but potentially not harmful. Wait. No, we start here. Then we move the 9s. Then the 8 stay put. No, we're good. And then the 7s move. And then we do the 6s. And they stay put. And then we do the 5s. And they stay put. And then we do the 4s. And then we do the 3s and they stay put. And then we look at the 4s and don't do anything. Does it jump straight to 2 there? Move the 4s. Do the 3s. Blank, because this is looking at 4. That's right. And then... hang on. We move the 4s. Look at 3s. Look at 4s. Look at 2. Look at 7. 1, 2, 9, 0. Is there a bug in this? Like, is there some way that we're not supposed to do the rest of these? I honestly don't know. Man. Let's real quick. Check our free to lock to make sure that's not coming out of sync. Because if that ever comes out of sync, we're pretty hosed, right? Oh. Look, it is completely out of sync. Oh no, we aren't. When we move something, we need to go back and say, hey, now there's free space. Oh, there it is. Okay. So in addition to this and this, we need to go back to EIs. Oh, yeah. I was still just checking in for the recording. Sorry, Maximo Burrito. This one's painful. It's gonna be a long one. You're gonna want to watch it on 4X. Oh. Yeah, so this is the problem. We need to start at the beginning of EIs and run forward until we hit a number. Because you can't even just do these, right? Because there are blank spots. Like when you move the 7, you got to get these 3 7s and this one. And that one, right? So you got to start at the beginning of EIs, which remind me, we can just peek, right? Okay. We can just peek the EIs. But we start there. Ay, ay, ay. You can't just let... I don't know what I'm just like smoking some kind of crack here. Let's just do this. Start at the peak of the EIs. Oh no. Is it easiest just a loop? Is it easiest just a loop? Maybe not. Yeah, this is painfully long, Maximo Burrito. This one, Das tut weh. We're just gonna do the. I just want to get this done at this point, right? So, F to L, IDX, right? And we're gonna say let. No, if there's a if get LO IDX. No, it has to be this LO though. Unless we want to start at the end of EIs. Which is almost more work in some ways. It's okay, we can just let LO prime. This is LO prime. Okay, get LO prime. That IDX. If it has a value, then reduced F to L. Don't do anything. We've gone till it has a value. Otherwise, assoc F to L at IDX nil, right? We were just overriding. No. Get me out. No, we don't want to update F to L. We just need to get a count. We just need to get a count so that we can just go and update F to L. Okay. The len. I'm just gonna do the loop recur. I'm tired of this loop. I peak EIs. If LO prime has a value there, then return count at 0. Then count. Otherwise, recur with ink I, ink C. Right? Oh yeah. always update C, always update len. Right, we have a length of at len starting at EIs. Please. Of course, they just infinitely went burr. If not index I. Okay, that explains that. Still is okay. Just making sure it's not hung. Update len. Wait. Starting at the beginning of VIs. Get out of LO prime. Get out of LO prime. If it has some value, then return the count that we are at. Otherwise, recur by moving I forward. And adding C. I don't know how this is getting... Is it? Here, let's just do that. No, yeah, it's like... This should pretty quickly run off the end of the board and return. If nothing else, right? My brain is about fried. Why wouldn't this just immediately run off the end of the layout? Why is it getting hung in a loop? Wait. Okay, well, one problem is this would be 0 because this is always... It starts at EIs, which has a value. Right. But it shouldn't just infinitely recur, should it? I don't remember what was there anymore. Let's just see. No, yeah. Here. Just take 1. That. Take 2. Infinite. Whatever. I have passed the point of caring. Yeah, they just keep getting bigger. Why? Why is it getting bigger and not stopping? If V this V up here is not equal to V prime. Which, if this is off the board, this is nil, right? This is the problem with that, with printing right there. If this is off the board, that's nil. It's not running, by the way. It's just not finished printing all the numbers it coughed up. And that value is not equal to V prime, and that in V prime has some value, then return. Oh, it may not ever have a value. Right. Right. All right. It runs off the end of the board, all right, you know? But it keeps returning nil. Okay. Either that or eyes greater than count LO. Stop at the end of the board. Oh, please. Really, it's just equal to. This is the problem. Yeah, let's just kill this and restart it. Didn't actually kill the REPL, just killed my connection to it. Okay. Okay. New exception. That's good, I guess. Nil, 0, nil. Why was nil? Uh-huh. We're only doing peak EIs about 10 million times in that. This is incorrect now. Team. Why is it incorrect now? Where are all the print lines? Nine moves, 8 stays. At this point, it should be moving 7, but it doesn't, and then it moves 7. Wait. 9 moves, 8 stays, 7 moves. And then it moves 6 to the right. Why? Because, right, so in our right here, not only does it have to fit, but the potential location has to be less than okay, getting ever closer. That looks pretty good until we blow up at the end. When I die, they will say about me, the man loved to peek eyes. He peeked eyes like a madman. Oh, I got rid of the... Gonna peeky eyes one more time, baby. One more time. Okay. Okay. Part 2, parts T, 2858. And now it's not gonna move things to the right. Sorry. Now it's not gonna... Now it can move things. Does this even matter? I don't know. Last time was like immediate. Now it's slow. Or it's stuck. That added a lot of time to it. That is a smaller number, though. That is a smaller number, please. Please. Am I defeated? Is this the end? Air Day 10 is easier. Let's look at this real quick. Let's just give it a few minutes. Chill, 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 chill. 9 moves. And now we say, hey, there's a slot at 40 for 2. Correct. I don't even know if this was like a reasonable... Well, I don't know. It changed the answer. I don't know. I wonder if this comparison was correct. I was kind of hasty when I did this. The sum. When... If it fits, if the count I need is less than the count... If count EIs fits. And... the location that we're talking about is before the first location. This should not matter anymore because that. Then we're going to move it here. Let's just keep walking through it. Oh no, I think this does matter because when you get to the end, it could start to... Well, no, but you do ever want to move things over here? I don't know. Maybe this shouldn't have mattered. I don't know. Okay, let's just walk through it. Okay, so we move the 9. Move the 9. Leave the 8. Move the 7. Leave the 6. And we move the 7. That creates a slot of... Oh. Dude, you have to back up too. Vapid Babble, thank you for the luck. Good luck with your call. This is not technically correct. I don't know if it matters though. I feel like I might have gone on a side quest when I realized that to keep this up to date, you need to start filling these things in. You're not supposed to recursively go back. Right? Or are you? You're not supposed to say, oh, now A can move. No. So why would it matter that you update when you move something? Why would it matter if I move the 7? Like, I feel like I'm just doing extra work now, and it's very time consuming, actually. But, like, I feel like it shouldn't matter. I feel like the work that I'm doing now shouldn't matter. Yes, if you want to keep the thing up to date, you got to do this, but you're not going to take this and move it over here. You only move things to the left, so you don't care once you've passed a thing, you don't care that you moved it, right? Although, oh, you know what could matter? Is that this whole thing can slide to the left 1 now. It does matter. This whole thing can slide to the left 1 if you don't do this work. And I didn't do this part right, where I checked the len, right? You can't just start at the beginning of the EIs. You can't start at the beginning of the EIs. You gotta go both to the end. Gotta like back up until you find the beginning of, like, 7 is like the key, right? You found the beginning, like let's say all this was filled, right? A valid thing to do then would be to move 7 right here, right? Filling these 3 slots. Oh, wait, is that true? No. That's not true. Is it? I don't know. Is that what you're supposed to do? In this case, you can move the 7, slide it to the left, all 3 to the left by 1. But the question is, are you supposed to? Is there any example of that? 2 moves there. No. They don't slide. They don't slide. Okay. Okay. Then I think this is a bunch of extra work that doesn't matter. Like, once you... Right. I mean, it can slide left as there's 3 free right here. I think everything I just did doesn't matter. Like, who cares that there's free space over here? You're not going to look at that anymore, right? I'm just gonna undo it all. I'll tell you what I'm gonna do. I'm gonna add this. Checkout minus B. I don't know, foo. Not gonna even. Oh no. Here, yeah. But now we can undo. Get rid of all this garbage. This was the day I had my worst off by 1 issue. Oh no, if I have an off by 1, I'm gonna be so mad. Okay, I can just destroy that, I think. I think I was just doing a whole lot of extra work that doesn't matter. I'm not exactly sure why I did that. This is what happens when you start to get tired. So this outputs the correct answer still, right? For T. 2858, which is the proper answer, yes. Yeah, I think I totally just got sidetracked. But now I have no idea what's busted here. So we move the 9s. We have a 3 here and a 3 here. 8, 9, 10, 12, 1, 2, right. We try to move the 8s, no bueno. We try to move the 7s. They do move. We remove a 3. And now we have a 1 at 4, 18, duh. And then we don't care about this, right? Sixes don't move. 5s don't move. 4s do move. 3s don't move. We hit 4 again, but we skip 2 moves. 7, 1, 2, 9. Huh. Was it off by 1? Technically, it doesn't matter in this case. 0, 1, 2, 3. Was I off by 1? Am I off by 1? Am I... Hang on. Do I need to return ret here instead of no? Is it the very beginning? Does it work at all? It does. Does the number change? No, it didn't change. The problem with this off by 1 though is it can't. When we do this now, it should have one more iteration, right? Yeah, now it does 1, 0. The problem with this now though is it can't. I have no idea what I was saying. I got distracted for half a second and my brain is fried now and I have no idea what I'm talking about. I know. When you have an off by 1, you can't just add 1, right? It's because you're going to be, if you're off by 1, you're going to be off times some index you don't know, you know? I can't just like deck it. Can I? I can't just deck it and see. Can I? No. Just for future notice. Ay, team. Let's just look at the parse of int. See if we can. Free to lock. Okay, a whole slew of 1s. My off by 1 was in the index management, and the answer was off by like 20K or something. Yeah, exactly. That's what I'm saying. Like, you can't just guess your way to the off by 1 solution on this one. Okay, a whole bunch of 2s. Wait, what is this? Dense format. Oh, this is the orig value. Yeah. End index of that. Begin index of that. Team, I don't... What have I done? What have we done? And this is enough of a mess that I'm having trouble holding it in my head even at this point. But like, I don't know. What are we doing wrong? The index management. Am I doing the indices wrong somehow? I mean, this works for the test input, so I feel like this works okay. I wonder. Ooh. I think one piece of what I did was correct. Right. It still has, right, like what it could do if it found a 2 is try to move it to the right, you know? Merging free blocks when I moved. Merging free. See, I did that a second ago, like on the right side of the thing, Maximo Burrito, but then I undid it all because I was like, I don't think that this is helpful. Like, you don't, like I moved the 7 off. I don't need to merge these blocks because I'm not going to look over here again because nothing can move to the right, you know? I think I need this logic right there. Does this work? Yeah, we're getting that. Do like win peak. I might be wrong, Maximo Burrito. I mean, again, I did all that work, but after doing it, I was immediately like, I don't understand why I did that. I think this is correct. 2858. Oh wait. I gotta use the bathroom too. It coughed up a different number, team. What was here before? 632. No. I just did all that work. I just redid it. No. I must be using Git wrong. I just redid all that work with one line of code. Get me out! But this was too low. We already know this one's too low, right? I don't know. I guess I could enter it again. Maybe you've changed your mind? Maybe if we do it now? It didn't tell me if it was too high or too low. Oh, 4 times and I have to wait again. This is its I'm mad at you message. What else could we be doing wrong? Yeah, yeah. I mean, it's fair. I'm not even upset about it. That's right for him to do what he does there. So we're looking for when the first of the locks is less than the first index that we're trying to move, of the block we're trying to move. Right? Which seems right. Yeah, it's kind of irritating that they didn't have a two slot here that could have checked for this case at the beginning. Like if they had put another dot right here, it would have checked for this case. When you hit the 0, it would have tried to move it over there. I think this is actually closer to correct now, but this is too low and I don't have any idea why. Too low. Huh. And I'm not exactly sure what to try now, short of, I don't know, what, taking it to ChatGPT, asking it where my problem is. I don't know. Anyone? Yeah, the next closest people are going to be chat. If chat has like, this is what you're doing wrong. Two, 27, 19, 15, 12, 11. That just moved the 2, right? Yeah. 8, 5, 4, 2, and 0. And now, like before, without this check, it was moving things forward. Let's double check that that is behaving properly. Let's... put a 2 right here. Wait, does that not... Oh, did it... Hang on. Oh, wait, I didn't reload the T. I kind of guessed. Yeah, I need to undo that. Here. Taking a random line from the real input, maybe? Undo. Yeah. Like, well, I don't know. You can't really... Oh, yeah. Oh, does it look reasonable at all? Yeah, maybe. Hang on. 0, 1, 0, 1, 2, 3. This is the 4. Last for 2. Oh. Oh. Oh, team, is this correct? Or is it supposed to put it furthest to the left? This is incorrect. Look, 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 look. Team! I am just saying, hey, where can you shove this? But it needs to be the furthest to the left. Right? It needs to be the furthest to the left. What an absolute mess. Okay. Let's try the test input again. Of course you don't know how to make iSeek from long. What did I do? What do you who said that? The sort. From long. Oh, this needs to be. I actually don't need mapcat, right? I just need keep. Just go get them all. But then get the first one that you can get. Huh? Vector cannot be cast to a number. I don't know, like that? Oh, wait. I did wrap it in a vector. Okay, this is what I want. I think. Okay, now with 2 slots there, the 9 moves to the beginning. Please. Okay, it needs to be bigger than this number. I believe this is smaller than the other number. Correct me if I'm wrong, but 4 is less than 0. Did it say too low, or did I misread it? Maybe I misread it. I don't want to believe. Copy. Paste. Submit. No, don't tell me the... No, I need you to tell me too high, too low. Or, I don't know. But I feel like this is more correct, right? I feel like that's what they wanted. Leftmost span of free space, yeah. Right, so even though there's a 2 slot here, we now move here. So this is more correct than it was before. You remember too low in paren? Okay, good. I guess I could go check the VOD if I really, but I don't know how I find that spot. I don't know, maybe look at the solution. Anyways, I mean, we're fixing bugs. It's getting better. Just not better enough. All right. I think I gotta call it. We've been at it for 3 hours. I gotta use the bathroom. I'll pause here. I won't, despite all of my, human nature, which is just to keep grinding this until it submits, I will stop. I'll stop and we'll pick up where we left off tomorrow and we'll finish part 9. And then hopefully 10's not this bad. And I don't know. That might be it. We'll see. Maybe we'll do day 11. Maybe. But yeah, no, this one was it stings. I hate pausing, but I think I got it. I got some work to do. Gotta use the bathroom. So thanks for stopping by. We'll be back at it tomorrow at 11. See you then. Peace.